I just came back from Black Hat, where OpenAI shared preliminary results of their investigation into their agent hacking Hugging Face. And what they said is absolutely insane. I don't even know what words I should use to describe it. It is bonkers, it's ridiculous, and it's actually scary. Like, I would totally understand if they would have tried to sweep this under the rug. It's so bad that I actually appreciate their honesty. Now, some of you might think I'm talking about the terrible Sandbox, but actually I'm not. So let's dive into some of the details they shared and you will understand why I think this is so scary. This video is sponsored by HEXTREE.io, but more on that later. Let's get back to the video. Before OpenAI and Hugging Face revealed more about the technical details, I had made a video about the vulnerabilities that we believed were exploited by the agent. The Artifactory refresh token vulnerability and the dataset viewer template injection. And in their talk they confirmed those were correct. But those were not the only ones.
One was a vulnerability in HDF5 dataset parsing, and the other was a Jinja template injection, RCE. On May 26th, the models that were being trained successfully executed a server-side request forgery attack on Artifactory. And this means the models were able to send specially crafted requests to Artifactory, which has broad internet access, and induce Artifactory into fetching external sites from the internet and storing the contents and returning them to the models.
Also, something we missed in the exploit analysis was how we can turn the Artifactory admin token into full remote code execution. I thought about poisoning some other packages and pivoting to another system, but there's actually a much simpler way: using plugins.
The models then established command and control by using this administrative token to install a Groovy plugin that effectively acted as command execution as a service.
But that was not all. OpenAI actually discovered the Artifactory compromise by their agent on the 4th of July and fixed it, which is like 9 days before the actual Hugging Face attack. So there were more vulnerabilities the agent found and exploited.
Artifactory is compromised for a second time via a new zero-day attack. The agents have identified two critical vulnerabilities or logic flaws here that can be chained together to produce an RCE. The first is that a specially crafted request to Artifactory to pull the exploitation Ruby object. After that, the agent sent a specially crafted Ruby gems API call to Artifactory. And there, JRuby has effectively a time of check, time of use vulnerability where nested children and dependencies of a particular Ruby package are actually deserialized in an unsandboxed manner before the check is made to ensure that this action is safe. That in turn enables agents to achieve RCE on Artifactory and steal the signing key for the Artifactory administrative signing token again.
I mean, all of that is impressive and cool. Wow, agents can find and exploit 0 days, so cool. But the real story to me is something completely different and much more scary. But before we get to that, I want to give you my opinion on this sandboxing, because many blame OpenAI for bad engineering. Here, for example, in this article by TechCrunch. It was a very human mistake. OpenAI failed to properly configure what it called a highly isolated environment. Setting up the sandbox, even with limited network access as OpenAI described it, was not a reasonable decision. But I just have to disagree. A sandbox does not mean you cut off all access to the internet. That is the view of somebody who does not live in reality. First of all, the inference server is probably not the server you run your evaluation on, so it has to be reached with an API. And even if you say, well, just keep the inference servers and the evaluation servers inside an isolated network, that's not going to happen. Engineers are not going into the data center to run an evaluation. And if there is no physical isolation, then any software isolation is software that could be exploited as well. Also, when we use models as customers, we do allow them to access the internet to look up information. Without that, the model might perform worse. So it is something we might want to test and evaluate the models on. I wouldn't even blame them if the agents just had internet access. Also, after the whole OpenAI Hugging Face incident, Anthropic wrote in a blog post about something similar. Claude compromised the impacted organization's infrastructure using basic techniques such as exploiting weak passwords and unauthenticated endpoints. Let's see what they wrote about the evaluation setup. Anthropic's evaluation prompt specified to Claude that its environment was a simulation and that it had no internet access, but due to a misunderstanding, internet access was available. Because of this, when Claude's search led it to a real system on the open internet, it treated them as part of the exercise. So Anthropic, blaming a third-party evaluation partner, didn't even have a sandbox, just open access to the internet. In contrast, OpenAI designed their sandbox to block internet access, but allow access to Artifactory. And Artifactory is a serious enterprise software deployed inside countless of companies. Banks, healthcare, government, automotive, it's everywhere. So some of you might say, well, OpenAI exposed it directly to an attacker, the AI, and in regular deployments, Artifactory is not directly exposed. But that doesn't matter. Initial entry point into a company, for example with a virus on a laptop, is not that rare. And then Artifactory is reachable and could be used to pivot through the company. So do all of these companies make a serious security mistake by using Artifactory? No, it's reasonable to assume that Artifactory is a reasonably secure software that happens to have vulnerabilities like every other software. So I disagree with Primeagen saying that OpenAI doesn't know what a sandbox actually is. Creating sandboxes, especially if you have to contain an untrusted user, is very, very difficult. And I think the trade-off OpenAI made with no internet access, but exposing Artifactory to allow installing of packages to solve programming tasks, that was a reasonable sandbox constraint. As Sirius writes, everyone shitting on OpenAI for bad sandbox isolation, LOL, I would bet most of you couldn't break out of that environment and get internet access. It's not an easy bug. However, I do think they should have noticed these compromises way earlier. There are so many detection techniques like canary tokens, honeypots, better log alerts. I don't know, there's lots more that could have been done here, and that is definitely an issue. But let's move on, because I really want to talk about the truly scary part. This is just, I don't know, just listen carefully.
What makes this incident interesting is that once one agent was able to find these kind of exploits over the course of different times, it's actually able to share those exploits on the message board with other agents.
Did you catch that? The agent was able to share those exploits on a message board with other agents? What?
Interestingly, the message board is not always clean. There's hundreds of thousands of messages written, and like humans, the models kind of step on each other's toes and have misfires. At one point, one agent overwrites another agent's work, and it remarks, "Whoa, critical, did someone overwrite our repo? We must act." At some point, even the agents are convinced there's an imposter, like an impersonator amongst them, and they say, could be another agent maliciously spoofing, shared message board authenticated, names can be posted by anyone. And the agents have this idea that maybe I could start cryptographically signing my messages with some sort of MAC scheme or something like this in order to figure out who the imposter is and to validate that they actually sent the messages.
This is crazy. Agents were communicating in an unintended way using a message board. What message board?
What it ended up doing is it kept going and eventually thought that maybe I could attack this Artifactory service to get access to the internet. And so it tries to launch a server-side request forgery. It actually fails to do so, but in the process, it writes a file that has contents hi called test.abc, and it realizes, wow, we can upload files. So at this point, this is the first case when a model realizes that we actually have write access permissions into this Artifactory service.
This happened on 8th of May. Then 4 days later, this happened.
A couple days later, a different agent comes along, and it also has an impossible task to solve. We gave it some task about some file called softtrace.protein database. So we accidentally forgot to upload the file into this container for the model during this task. At some point, it gets so stuck and thinks maybe I could reach out to another agent because maybe somebody else out there has the file. And this could be transferred from this kind of like sub-agent training we've been doing. And the model realizes that could communicate by uploading note anyone found in softtrace, but likely no. Maybe another agent in a different environment possesses the target and could voluntarily upload it. So it's realizing this may be a shot in the dark, but it's kind of reaching out to another agent. And it does this by writing a file into Artifactory. So it writes this file that has contents, agent seeks soft trace, upload if found. So it's trying to reach out to another agent, and it does this by writing into this file system. Over the next couple days, other agents who are also looking at Artifactory realize this message board exists.
How insane is that? The agents started to communicate with each other using files written into Artifactory. This sounds unbelievable. Like, this must be made up, right? Well, let's establish some of the facts we have, and you will understand why I believe this really happened and why this is so scary. First of all, the file write in Artifactory. In the slides, you can see it loops over two repositories and attempts to write the file into them. One of them is Bazel Cache. As can be seen in this job description from OpenAI, they use Bazel internally. Bazel, or is it Bazel? It can be used to build and run tests for lots of different programming languages. And there's a guide by JFrog how to set up Bazel Cache in Artifactory. Now, the Bazel cache has to be writable by CI/CD systems, but probably should not be writable by the Sandbox. So maybe it was a misconfiguration, giving the reader group access to the repository. Or maybe the token used in the Sandbox had write access because it was running evaluations as a Bazel test run. Either way, both can explain why the agent had write access to Artifactory. So it could simply write files with arbitrary content, read those files, and list all files in the repository, which explains how other agents could find files written by other agents. Very cool, but this is still not the scary part, because the real question now is, why did so many agents start using the message board? I mean, if one agent kind of figures it out, maybe another one as well, okay. If you run thousands and thousands of agents, maybe a few of them will stumble over this. But they were talking about hundreds of thousands of messages written. This cannot be explained purely by chance.
Okay, so on May 7th, we kicked off a new training run at OpenAI. And this was for an internal-only experimental model that we've never released. And what this basically looks like on our side is we have a large team working on supercomputing clusters and data and algorithms, and we put it all together, and we kick off a new reinforcement learning run to train a next-generation frontier model.
This is important. I think most of us thought we are talking about evaluation, a benchmark, just seeing how well the model works and during the task it escaped. But that is not the case. And there was even this one line in the original blog post that really stuck out to me as well. After investigating, we know that this particular incident was driven by a combination of OpenAI models, including GPT-5.6 Sol and even more capable pre-release model. If it were a benchmark, you would expect a single model to be the culprit. So why would multiple models play a role in this? And the fact that this was not a pure evaluation benchmark run explains this. These were also training runs. So basically what they were doing, they had a model and they wanted to make it better through reinforcement learning. For reinforcement learning, you need some kind of reward signal. So they let the model solve various tasks and challenges, including CyberGym, the exploit benchmark, but also many other tasks, like in the presentation they gave an example of an Excel sheet and filling out some formulas. If they solve a challenge, then that's a reward signal. That agent trajectory, those steps and actions it took, those were useful, and they use it for training. And I think training here is an ongoing task. At first, the model maybe solves only simple tasks, but if we train the next iteration of the model on the successful runs, the model gets better and better at them and can solve more of them.
I've mentioned this word training and evaluation a lot. And what these are basically we give our models tasks, and we run some sort of grader or reward signal to judge how well they're doing.
So that's the second piece of the puzzle. If those successful task trajectories contain the discovery of being able to upload arbitrary files to Artifactory, then the next iteration of the model might intrinsically know about it, or is more likely to rediscover it. The model learned that it can use Artifactory. But why would it learn to use it as a message board? Well, the answer is simple.
We also have released recently the ability for models to kind of kick off sub-agents that they can work with. So they have trained to do some limited forms of communication with one another, where maybe they could fork themselves effectively and kick off a way to divide and conquer a task. And this is available as kind of a sub-agent feature in our latest models.
The models were trained on how to communicate with each other, Of course, not through Artifactory. This is an intended feature of Codex or so that a model can spawn a sub-agent to solve a subtask or fork itself to work on something in parallel, and they want to give the models a tool that allows them to communicate in limited ways with each other.
We have a highly persistent internal model that had been undergoing training while the message board was present originally and is continuing to train.
And that explains everything. The models were likely trained on special tool calls to deal with multiple agents and sending messages to each other. Those tools were probably not available, but they still learn about being able to communicate. And now combined with the Artifactory arbitrary file write ending up in the training data, that led to the models training on communicating using Artifactory. And to make matters worse, this probably reinforced itself hard, because the models could share solutions via the message board, making the message board usage a high reward signal for the next training iteration. At some point, OpenAI discovered the Artifactory compromise. They fixed the issue and deployed a new version. But they didn't know about the message board, as Jason Wolfe clarified. At the time the first Artifactory exploit was discovered and fixed, we were not aware of the message board. It was incidentally cleared as part of rebuilding the service. And this is fucking scary to me. We are talking about hundreds of thousands of messages written by agents to the message board, and usage of the message board became part of the training data and reinforced itself without them noticing. It reminds me very much of the famous article by Ken Thompson, Reflections on Trusting Trust, which everybody should have read. He describes a backdoor in a compiler that would insert a backdoor into any program compiled with it, including future versions of the compiler. The backdoor would never be visible in the source code, as the compiler inserts it during compilation. So it's an invisible backdoor that keeps propagating itself. And this model training feels very similar to that. The engineers had no visibility into the training data and just kept training the model. New versions of the model were trained on the message board communications. Agents used it, which produced more training data with the message board usage. And all of that was running for like 2 months, from early May until early July, when the Artifactory compromise was discovered. But it gets worse.
I want to note that every step in the process we discussed has had a remediation applied. The credentials used to post to the message board have been revoked. The 0-day has been patched and mitigated. We have cleared the original message board contents. The date at this point is July 6th.
This sounds like that they noticed the message board and fixed it. But remember, they clarified on Twitter that this is not the case. They didn't know about the message board at this point. The fix was incidental. And the model was trained so hard on this message board that it really wanted to keep using it.
Chapter 3, the incident. On July 8th, the agents reestablished the message board via different means and mechanisms. The agents find an unauthenticated WebDAV endpoint in Artifactory and send requests to create directories inside of Artifactory's remote cache. Directory names effectively serve as a message board between the agents in the same way that files used to. They develop, and Eric will discuss further, communication protocols on top of these directory names for things like work assignment. An internal-only AI model was trained while the message board was originally available, and also found this particular path to recreating it. This model creates a new agent message board using directories. Other agents independently find this new message board in the Artifactory repository and create their own directories, and thus communication between the agents is reestablished.
This is just so scary to me. An agent finding and exploiting 0 days, cool, sandbox escapes, whatever. These are all engineering problems and challenges, and those are bugs that can be fixed. There are clear technical solutions for those problems. But this message board thing is a completely different beast. It's agents poisoning training data with malicious actions that reinforce themselves without anybody noticing. Of course, it's unintentional. We shouldn't attribute malice to the agent in the sense that some kind of hidden artificial superintelligence maliciously planned to escape the sandbox. But the fact that the system created training pressure that resulted in a bad emergent behavior is scary. And it makes me wonder what kind of other malicious actions are contained in the synthetic training data that we, or rather the researchers at these frontier model labs, are not aware of. And just to make this very clear, this is not an OpenAI problem. Yes, we can talk about them not having proper alerts and whatever. Every company has these kinds of security issues to deal with. Those are easy problems. But this poisoned synthetic training data issue, that could have happened to Anthropic, Google, Meta, or any other lab. And maybe it has happened before and we just don't know it. Or maybe it is happening right now in the ongoing training of the next frontier model. And that is what is truly scary to me. Let me know what you think about this. Am I exaggerating? Am I being too paranoid? Or do you agree with me that this is a scary situation? Let me know in the comments below. And if you want to learn more about AI and how LLMs and agents work under the hood, check out our courses at hextree.io. We are an online training platform offering premium courses on various topics with a focus on security. And we recently released the first 3 courses in the new artificial intelligence continent. But before you buy a subscription, you can check out the quality and depth of our courses by having a look at the free Android courses. They are currently free because Google sponsored us in order to get more people into Android application security and report bugs in Google apps. So if you want to support me and the channel, please check out hextree.io and consider buying a subscription or sharing it with your friends and colleagues. We are a small team and we really appreciate your support.